Hello, my name is Rinaldo Fernandez, and today I will be presenting the HIV and AIDS pandemic. So first, we gonna do an overview of what HIV is. We have to ask these two questions. These two are important questions. What is HIV, and what it says? What is the difference between each? Are they the same? Are they different? How are they related? Now, after that, we have to ask how it works in the body. How does the infection starts in the body? How does it spread through the body? And how it gets to the point that people die. Then we're gonna talk about more about the history of the pandemic, the origins of the pandemic, very, very early cases of the pandemic, and also a timeline of the pandemic throughout 40 years, starting from the 1980s to today. Then we're gonna talk more about formal treatments that were developed and that we still have today to treat HIV infections, and also prevention and social cultural impact. Our first question is, what is HIV? HIV stands for Human Immunodeficiency Virus, and it's a virus that attacks the body immune system. It's a virus that spreads through the interchange of bodily fluids like sexual fluids, blood, and even breast milk. In this case, for men, it will be semen, and for women, it will be vaginal fluids. When these two types of fluids come into contact through unprotected sexual intercourse, then is when HIV infection starts. And then through the blood is when two people, one that is infected with HIV, shares the needle with somebody who's not infected. And that's when we have a blood-to-blood infection of HIV. And then breast milk is through mother and child, which usually also happens. HIV does not spread through everyday contact like hugging, sharing food, nor touching the same objects. And also, this goes to saliva too. These statements is very important because when HIV started, many people did not want to be around people who are sick with HIV because they thought that sharing their saliva, hugging them, kissing them, they will get the virus, and that caused a lot of stigma around the world of people who have HIV. But later, it was proven that through these ways, HIV um is not transmitted. It's only through body exchange of bodily fluids. Without the proper treatment of HIV, it can lead to AIDS, which is a final and most severe stage of the infection. So the difference is that HIV is the virus itself, and then AIDS is the disease that is caused by HIV. It's a later stage of the infection of HIV. That's basically the main difference between these two, because many people still think that they're the same thing, but they're not. The only difference is that the one is the name of the virus itself, and the other one is the infection and the disease caused by the virus. Now we're gonna talk a little bit more about the structure of HIV. The shape of HIV is basically a spherical virus with an outer envelope approximately of 120 nanometers in diameter. As you can see in this picture, it looks very round-like shape, and it's basically a spherical. Mm. And then the envelope outside is made of lipids with spike proteins. As you can see here, these are the lipids and the proteins. That these are the ones that attach to the CD4 cells. These attach to the CD4 cells receptor, and then from there the infection continues, and then virus enters into a cell. And then a key thing to point out, that I will show in later slides, is that the spike proteins that we see here in pink is different for each strand of HIV. We're not gonna have the same type of spike proteins in each strand of HIV. We're gonna have different types of of spike proteins. And then the capsid inside of the outer envelope, we have a capsid that is cone shaped core inside of the envelope, which is made of P24 protein. But for HIV, other types of HIV, It's made of other proteins. It can be P23, P26. It all depends on what strand we're talking about. And this is the most common type of HIV, which is HIV one, the one responsible for the global pandemic around the world. Then the genetic material of HIV is two copies of RNA inside the capsid. So HIV is a RNA virus. It belongs to the family of retroviruses, which I will be talking more later. And then we also have enzymes like reverse transcriptase, integrase, and protease that help the virus copy itself and insert it into the host cell. Then how we classify HIV? HIV is a retrovirus, like I mentioned before, which means it carries RNA instead of DNA. It belongs to the virus family called lentivirus, which are type of viruses known for causing slow and long-lasting infections. And this is a very, very characteristic of HIV. Then retroviruses like HIV insert their genetic material into the host cells, making the infection lifelong. There are two main types of HIV. Like I mentioned before, HIV-1 is the most common type of HIV found worldwide. And then we have HIV-2, which is mostly found in West Africa and spreads lower than HIV-1. Now, talking a little bit more about HIV-1, HIV-1 is the most common type of HIV in the world. It's responsible for the global HIV and AIDS pandemic. So this is the strand of the HIV virus that is responsible for the pandemic itself. It spreads easier and multiplies faster in the body than HIV-2. Then HIV-1 has several groups, is categorized even into further groups called M, O, and P. And Group M is the main pandemic group around the globe. So basically, the Group M is the one that causes the most infections around the world every day. Then Group M has also many subtypes, like subtype B, that is common in the US, Europe, and Latin America, and then subtype C, that is most commonly common worldwide and in Africa and also India. So subtypes of HIV are basically the region where the HIV that type of HIV is found is connected to the subtype. Subtypes are linked to the geographical location of HIV. And then HIV-1 causes stronger drop in CD4 cells if it is left untreated, and then progresses to AIDS way, way faster than HIV-2. And then in this picture, as I mentioned before, HAV1 and HAV2 are made of different spike proteins attached to the lipids. So as you can see here, when this inside in the capsid, HAV1 is made of P32 integrase, and HAV2 is P34 integrase. So it's different. The difference in the proteins is what causes the difference in the rate of infection that both strands causes in the human body. HIV-2 is mostly found in West Africa, but it's also seen in some parts of Europe and India, but it's not as common as it is in Africa. It spreads slower and is less infectious than HIV-1. Usually, somebody who gets infected with HIV-2, the lower it has a lower viral load in the blood, and basically what this means that the amount of virus of HIV virus per unit of blood is way lower than somebody who has HIV-1. It also does not spread as easily through central contact as HIV-1, and then it takes longer to weaken the immune system. And then many people with HIV-2 stay stable for years without AIDS. So, for example, we may somebody who gets infected with HIV-1, and if it is left untreated for like I would say 3 years, the infection develops really quickly, and it leads to AIDS very fast, and then it leads to death also very fast. And then somebody who has HIV-2, who gets infected with this strand, they can stay stable for like around 5, even to 6 years after going into AIDS. And then some HIV-1 medicines do not work on HIV-2. As I repeat this, the two different strands of the virus are different. They have different proteins. What works for one type of strand, it will not work for the other one necessarily. So this is a very important takeaway that we need to consider. And then an example of why medicines do not work is because protease inhibitors are less effective in this type of HIV. For example, a, protease inhibitor that targets P32 cell will only targets P32 proteins, but since only that is found in HIV-1, it will only work in HIV-1, but it will not work in HIV-2 because the integrase or protease of HIV-2 is made of P34, not P32, the one that is specifically being targeted. But overall, HIV-2 infection is still serious, but it's overall milder than HIV-1. And then we get to the part that how HIV attacks the cells. First, the spike proteins that I mentioned before dock in the CD4 receptors and co-receptors of a cell. And then after that, we have the fusion stage where the virus loads its viral RNA inside of the cell, then through the use of reverse transcription and also through the use of reverse transcriptase, that is the enzyme responsible for doing reverse transcription, produces cDNA, which then leads to double-stranded DNA of HAB, and then that double-strand DNA gets integrated inside of the chromosomal DNA. So then the cell will start producing these viral DNA, which then will make more HIV viruses, and then will be released into other cells. So CD4 cells is the main target of HIV. Is a specific HIV is very specific to CD4 cells and other immune system cells. It mainly attacks CD4 T helper cells and also infects macrophages and dendritic cells. As we know, macrophages is the types of immune system cells that basically eat all of the bacteria that we get that we have in the virus in the body, the bacteria that we get from infections, that the macrophages are responsible for that. The virus attaches to CD4 and then to CCR5 or CXCR4. So CCR5 and CXCR4 are the genes that basically the double-stranded DNA gets to attach, and this part of the chromosomal DNA is where the HAB starts being produced. So basically, a fun fact, some people have a genetic mutation in the CCR5 gene that causes the receptors of their cells to not be specific to HAB. So basically, these people cannot get infected with HIV because they have a mutation that doesn't let HIV dock into the receptors of their CD4 cells. And then it inserts the viral DNA into the host DNA, and then the cell becomes a factory that makes up new HIV viruses, and then this produces a chain reaction that it will infect to other cells, and those other cells will keep producing new HIV viruses. And then the new viruses break out and infect more cells, and then the CD4 counts drops over time, and basically the immune system shuts down. And then we get to the question of what is AIDS? Basically, AIDS stands for Acquired Immunodeficiency Syndrome, and it's the final and most advanced stage of HIV. It happens when the immune system is very, very weak and the CD4 counts drops below 200 cells per millimeter cube. And then after this is when we have certain infections, serious infections, and cancers appearing in a person's body because the body cannot fight off germs like it normally could, uh, like it normally could. And then basically the innate immune system shuts down. It also doesn't fight off germs like it normally could, but it doesn't fight abnormal cell growth, which is basically cancer, like it usually does. So that's why we also have cancers appearing in people who have AIDS. And then without treatment in AIDS, it's a life condition, so that can cause um, without treatment of AIDS, it's a life-threatening condition that can cause death later on. Then some symptoms of AIDS, very fast weight loss. This is because at some points the cells start deteriorating and dying, and then we start losing body mass as a result of AIDS. And then we also have extreme tiredness and weakness, mostly in the muscles and joints, which is very common symptom. Then we have long-lasting fever and night sweats. The body basically does this as as a like a trigger to get rid of the infection of the body, but it will last a bit more for the fact that we don't have bacteria being getting rid of the body using fever is a virus which is more resistant to this. And then we have swollen lymph nodes because, as I mentioned before, HIVs attack CD4 cells, and lymph nodes are the factory of immune system cells. They basically produce a great majority of the immune system cells, and then the HAB attacks specifically these lymph nodes. And as I mentioned before, HAB was discovered in isolated uh, lymph node. And then chronic diarrhea doesn't go away. It's also a common sign. And also we have white spots and sores in the mouth who look like herpes, and also that caused a lot of misinterpretation that they thought that people who have AIDS have also herpes, but it's not. It's just basically a source that develop around the mouth, which are look similar to herpes, but it's not. Herpes is a different virus, completely different from HIV. And then we have also shortness of breath and constant coughing. And then we have also frequent infections. These are the common signs of AIDS. And then further complications of the disease is opportunistic infections. These are infections that normally don't make healthy people very sick. For example, we can get sick of a common cold, but in 2, 3 days, we can be fine. The common cold is like something common and doesn't usually cause death. But when somebody gets the common cold while already having AIDS, it can usually cause death because the virus is not fighting other bacteria, other viruses that are inside our body and who are causing infection. That's why these people get very sick of even a common cold, which is something that by drinking tea, Tylenol, or Theraflu, it will help you to feel better. For them, it will not make them feel better. And thus, then without a weak immune system, they become life-threatening conditions like pneumonia, tuberculosis, bacterial, and even fungal infections. Cancers linked to a weak immune system. HIV increases the risk of certain cancers, like I mentioned before, because the body cannot fight off abnormal cells. These types of cancers are like Kaposi sarcoma, which causes dark skin lesions and can affect organs. So this is an example of somebody who has Kaposi sarcoma. And then lymphomas affect the immune system cells and can spread quickly because we have a network of lymph nodes around our body, and then lymphomas are basically abnormal cells growing in the lymph nodes. And since this is the basically the factory of HIV in the lymph nodes, then we have a faster spread of HIV. And then we also have brain and nerve problems. This is very common. HIV can affect the brain when the immune system is very weak. People may deal with memory loss, confusion, mood changes, or even nerve pain. In severe cases, it can lead to problems with movement or thinking clearly. Usually, people who already have already gone to this point of the HIV infection are bedridden because any slight movement that they make, walking or moving their arms, moving their heads, causes them extreme pain, and also because the body makes a trigger by creating inflammations around the joints due to the infection. So this is why also people get these symptoms. Now we're gonna talk a little bit more about the discovery of HIV. HIV was discovered by Mr. Montagnier and Francois Sinousou in 1983 after doctors noticed unusually infections in young men. Scientists found that the patient's immune system were very, very weak for no clear reason. And then in 1983, these two guys who were researchers at that time in France identified a new virus in lymph nodes that were as attacking immune system cells. And then at first it was called lymphadenopathy associated virus or LAB because it was found in lymph nodes, but then it was later named human immunodeficiency virus. And these two guys actually won the Nobel Prize of Medicine in 2008 for the discovery of HIV. And then how was the HIV proven? Because this is a good question to be asked always. If you think that there's a new virus um, around, we have to prove it. So what the scientists did is that they found HIV in almost every patient who had AIDS. So we also had to prove that we're making a connection between HIV and AIDS. So the virus was shown to destroy CD4 T cells, which explains the immune system failure seen in AIDS. Then the lab study showed that if HIV infects cells, copies itself and spreads throughout the body through the lymph nodes. When HIV is treated and controlled, AIDS does not develop, and that proves the connections between HIV and AIDS. In this picture that I put here, this is an isolated tissue sample from someone who has AIDS, and this is a isolated tissue sample from their lymph nodes. As we can see here, there's this is the HIV virus, and these are the immune system cells which are being attacked by the virus. Then, this is a very complicated topic, the origin of HIV, because to this day we have an idea of how the virus started, but we don't have a clear explanation of who was the first person to get infected. That is like impossible to know because around 100 years have already passed since they believe that HIV started. So basically, HIV originally came from a similar virus called simian immunodeficiency virus, which affects African primates. Then they jump from the chimpanzees or primates from animals to human, likely happened when in the 1920s people were hunting chimpanzees, monkeys, and exotic animal meat, and they were hunting them, butchering them, and also eating them. And then it exposed the human's blood to the infected animal blood. So after this, the virus stayed in a human, and then it adapted to humans, and then it lead to a whole different virus outside from a simian immunodeficiency virus. The earliest known that we have today infection in humans dates to 1959 in Congo, and the rapid growth of African cities and increased travel and changes in trade and transportation helped the virus spread from local villages like in the Congo to large urban populations, and then from large urban populations in Africa, then we have a spread through across the globe. From the virus, from there, the virus slowly spread worldwide, becoming recognized in the early 1980s once doctors noticed initial infection in young men. The earliest HIV cases. So basically, we have a tissue sample or blood sample from 1959 of a man in Kinshasa. Kinshasa is a region in Democratic Republic of Congo, and they had preserved a blood sample from someone who was infected, who had an infection, and it was later discovered that it was HIV in 1959. And then 1960, we also have a woman who also tested positive for HIV from the same region. And then in 1977 to 1978 is when we have a Norwegian family that got infected and they all died because the husband, who was a sailor, he went to Africa, to Congo. He got infected there, and then he got his wife infected, and the wife was pregnant. That well, got pregnant, and then the child was also infected. It was later confirmed that it was HIV, the one who killed the family. But at this point in time, we didn't know that there was even something the HIV even existed. And then we have late 1970s. We have store blood samples from here from the U.S. which found that in San Francisco and New York, which we found HIV. And then in Haiti, we have Haiti was the first country in the Caribbean to have one of the earliest HIV infections and cases. And then we have the patient zero myth. So basically, the patient zero is the first person to have the disease and spread it through other people. So the CDC at the beginning of the 1980s, they made a misunderstanding in the reports, and they named a flight attendant called Gaten Dugas was wrongly labeled as the first person to bring HIV to the U.S. But later genetic studies proved that he was not the first case in the United States to be contagious with HIV because the virus was already spreading in the US years before he was diagnosed. So, but something that we can precisely say is that him he spread the disease to around other eight people. Eight other cases were linked to him, and those other eight people spread it to other people, and that's when we have the start of the pandemic in the United States and San Francisco. And then this label created unfair blame and stigma towards him and the gay community. Since Douglas was a gay man, this created a very, very bad stigma around the gay community, and people even call it that HIV was not a virus. It was just a gay virus, which was wrongly named during this time. And then today scientists agree that there was no single patient zero for HIV because it had already been spreading quietly for decades before the 1980s, which is the start of the pandemic. So this is a timeline of the virus. In 1981, first official AIDS cases reported in the US. We didn't know at this time people who had HIV. We didn't know how to treat it. People didn't want to even get near these people because they didn't know what they had. Then by 1983, the virus is identified. 1985 is the first HIV blood test created because what happened is that okay, we have the pandemic starting around 1981. People were still donating blood without even knowing that they were sick with HIV. So these people had an infected blood transfused into other people who were healthy, and these people who were healthy got infected with HIV, and that's why we that was a start of the pandemic because people who didn't have sexual contact with others were getting sick, and then they found out that's because of the blood. And then after 1985, that became a standard procedure of blood screening where everybody donates blood today, and they go through a screening to check if their blood is fine, if it is good to donate to other people, and the first thing that they test is HIV. And then 1987 is when we had the first HIV drugs called ACT. It was approved. And then by the late 1980s, global cases rise so fast, and strong stigma and fear are produced. And then 1991, then we have the red ribbon, like how the breast cancer awareness is a pink ribbon, then the red ribbon becomes a symbol of HIV awareness. And then by the early 1990s, many deaths worldwide are due to the lack of an effective treatment. So this is basically a progression of HIV in the blood. Then around 1995 to 1996, the drug cocktail therapy was introduced and survival improves. The drug cocktail therapy was like composed of like three drugs that cause good outcomes in people who had AIDS and HIV. And then that's when we have the death rate to drop sharply in developed countries. Then 1996, we have the first organizations founded to fight the global epidemic. Then the late 1990s, we have where testing becomes more available and public awareness grows. We have in campuses, in school, people protesting. That's when we have to bring awareness to people and to about HIV. And that's when we have the first HIV test kits to prove to know if you had HIV and things like that. And then early in 2000s, more affordable HIV drugs being reaching the low income countries. Now, in 2003, the PEPFAR launched major US program funding HIV treatment worldwide. Then 2006, CDC recommended a routine HIV testing for everyone ages 13 to 64 who were very sexually active and also had unprotected sex or had an encounter of sharing needles between two people. And then in 2012, the FDA approves PrEP, a pill that prevents HIV. And then more countries begin free or low-cost treatment programs. And then mother-to-child transmission drops with new prevention programs. No, so now we're talking about the mother can get tested to know if they had HIV. And we have even drugs that prevented mothers from infecting their child through breast milk or through just pregnancy. In this diagram from the CDC, we see that by 1993, when implementation to fight HIV was done, the the number of AIDS cases in men started decreasing very rapidly when awareness started happening. And then from 2010 to 2022, then in 2020 to 2015, the UNAIDS sets a global goal of ending AIDS as a public health threat by 2030. And in my honest opinion, I think we're getting to this goal because every day there's new HIV research done, new discoveries made, and they are making a good progress in reducing the HIV infections. And then between 2017 22, new long-acting HIV drugs are developed for people to live even longer lives. And then EU equals EU confirm undetectable virus equals untransmittable. And then PrEP uses increases around the world. And now in 2025, HIV is no longer seen as a death sentence. It's treated as a chronic and manageable condition. Okay, so now we're going to talk more about the first treatments that occur. In 1987, ACT or zidovudine becomes the first approved HIV drug. ACT worked by blocking the virus from copying its genetic material, which slowed down how fast HIV spread in the body. These types of drugs help a little bit, but the virus mutated fast and they weren't as effective over time. So we had to wait almost 10 years in 1996 when HHRT therapy was introduced that were three drugs taken together. And this new combo of therapy hit the virus from different angles, making it much harder for the HIV to multiply. And it marked the first major drop in death rates and slowed down the infection enough for people to live long term. And now the modern treatment is the ART, which just stands for antiretrovirus therapy, uses antiretrovirus drugs in one pill. These drugs stop HIV from copying itself so that the virus cannot spread to new cells. When then the virus cannot copy itself, then the immune system gets stronger again, can start fighting germs, start fighting infections, can start fighting abnormal cell growth. And we don't have people developing cancer anymore. We have people surpassing common colds and things like that. And then ART can drop the viral load to undetectable, which means the virus is so low that the test cannot even find that it are not, and it's not even transmittable to other people through sexual contact. Now today, there's a daily one pill treatments that prevent the infection from getting worse, or long-lasting infection injections work the same way by keeping the drug level steady to block HIV from multiplying. It's like an injection that you get every like 2 to 3 months around that time, and then with mother treatment, HIV becomes a manageable life condition instead of a deadly disease. And then this is a very important slide. U equals U. Undetectable equals untransmittable. When a person takes HIV treatment every day, the virus can drop to undetectable level. Undetectable level means that the amount of the virus is so low in the blood that it's not possible to transmit it to somebody, even though you're having sexual intercourse without protection. And then and then a person with undetectable viral loads cannot pass HIV to sexual partners. And this only works if the person stays on treatment and gets regular checkups every now and then. And these reduce the stigma and show that the treatment protects both health and relationships between two people. And these are just some basic preventions against HIV: to use condom regularly and correctly every time. Do not share needles or injection equipment because blood-to-blood infection can happen. Get tested regularly. Tested regularly if somebody having unprotected sex very often with multiple sex partners. And then take PrEP if you're at a higher risk of getting HIV, or use PEP after possible exposure. So now I'm gonna explain what is PrEP and what is PEP. Okay, PrEP stands for pre-exposure prophylaxis, which is taken before possible exposure to HIV. This is just like a daily pill or an infect or a shot that you get, and it lowers the chance of getting HIV from sex by over 99% when taken correctly. Now, when PrEP was approved by FDA in 2012, it was like over 90% effective. Now it's like over 99%. So if you take this every day, there's like the chances of you getting HIV are so minimal. And then for people who want ongoing protection, yeah, this usually what those people prefer. And then PEP is post-exposure prophylaxis. This is taking after possible exposure like unprotected sex, needle accident, and assault. And must start within 72 hours. The sooner the better. So after the attack or the unprotected sex, if you feel like you're unsure, you should go take PEP because it's a 28-day treatment that lowers the chance of getting of the infection. And also, it's meant this is meant for emergency situation, not regular use. So PrEP is for regular use, and PEP is used for emergency situations. And then the social impact of HIV and AIDS is that it brought stigma and discrimination. People with HIV face fear, isolation, and a lot of prejudice. It impact on many communities like the gay, Black, and African American communities were hit hardest early on because these three communities were significantly affected by the HIV infection. So it brought a lot of prejudice to against these three communities. And then activism and advocacy, groups push for better treatment and education and rights. Nowadays, there's many organizations who who provide activism and advocacy for HIV and also lead to changes in healthcare. HIV and AIDS lead to more testing, safer blood supplies, and public health campaigns, and also decrease the price in HIV medication, HIV tests. You can get nowadays HIV tested for free. You can get PrEP for free, even PEP for free. It changed the healthcare a lot. And also cultural influence in art, media, and literature address HIV and raising awareness worldwide. And specifically in the art and media, when we saw that some famous people like Freddie Mercury, Magic Johnson, and other ones started coming out saying that they were infected with HIV, and then people saw that this is just a disease. This is not a life sentence. This is something that can be prevented. And these people in the arts and the media help bring more awareness to the world. And now, how is the pandemic today? Since the epidemic began in around 1980, over 40 people million have died from AIDS-related illnesses. About 80 million people have been infected with HIV in this course of 40 years. Millions of people live, around 40 million people live today with HIV, most of them on effective treatment, and then modern medicine allows HIV to be manageable and to be a manageable chronic condition. And then prevention programs like PrEP, PEP, and education continues to reduce new infections. And then HIV and AIDS have changed the world a lot because showing the importance of science and activism and compassion between human beings. And then in this graph that I included here, it shows the death rate in the world of HIV. As we can see, we until around the year 2000, the death rate by age group was very, very high. And then now around in the 2020s, we see that death rate is very, very low. And since this is a little bit outdated in 2021, in 2025, we see that it even has an even lower death rate. And this is basically my presentation. And these are some resources that I use to obtain my data and my information. So thank you for listening.